Welcome to a new episode of the podcast. Vox Agent is made by AI for business executives that work with AI. If you're listening, you've undoubtedly felt the incredible pull of AI, right? Seems like every business is trying to figure out how to harness its power. But, beyond getting a cool demo, what's the real secret to making AI truly reliable, scalable, and impactful in a business setting?
That's a really critical question for any organization looking to move beyond just, experimenting with AI. For a while, the approach felt rather unstructured, maybe. This deep dive is all about a fundamental, powerful shift in how we build enterprise AI, moving from what we've maybe called vibe coding to a much more disciplined, robust approach known as context engineering.
Okay, context engineering. So our mission today is to unpack what that actually is, why it's rapidly becoming essential for any enterprise serious about AI, how it works behind the scenes, and importantly, what this paradigm shift means for your organization. It sounds like it's truly about getting to the core of what makes AI perform effectively and reliably, turning those exciting demos into consistent high ROI business tools. Right, so let's start by clarifying this idea of vibe coding. Because for many of us, our first interactions with large language models, LLMs like ChatGPT, felt a bit like, an art form. You type a prompt, get an answer, then constantly tweak the wording, maybe adjust parameters, add examples, kind of relying on intuition until you got something that just felt right. It was fast, short, and incredibly creative for prototyping, but it seems incredibly inefficient for a large organization. What's the biggest risk it introduces, beyond just scalability, that context engineering solves?
You've perfectly captured that improvisational nature of vibe coding.
Yeah.
And the biggest risk it introduces for enterprises. It's unpredictability. And honestly, a massive talent drain. When you're programming by vibes, consistency is, almost impossible. Outputs vary, errors are really hard to trace, and the knowledge of why something works often lives only in the head of a few, prompt whisperers. This simply falls apart when you need auditability, reliability, and the ability to scale your AI solutions across diverse teams and use cases.
Right, okay.
And that's precisely where context engineering steps in as the mature, disciplined alternative. It's a structured methodology for systematically designing all the information and inputs an AI model receives. Think of it less as just prompt crafting and more like architecting the full context for predictable, reliable outcomes.
So it's not just about the prompt text itself then, because I've heard a lot about prompt engineering and it sounds similar. What's the most common misconception you run into there?
That's a crucial point, yeah. Prompt engineering, in its traditional sense, is certainly a component of context engineering. It's about carefully crafting the text instructions. But the misconception is that it's the only thing that matters. Context engineering is much, much broader. It recognizes that a successful AI output depends not only on the immediate prompt, but on all of the supplemental information. Things like system role instructions, the conversation history, any external knowledge it needs, tools the AI can use, and even the desired output format.
Can you give an example?
Sure. So instead of just asking an AI, say, summarize this contract, a context-engineered approach would bundle more in. It would include role-playing instructions like you are a legal assistant, maybe relevant clauses retrieved from a secure legal database, specific formatting instructions, examples of good summaries, all fit in as part of the model's input context.
Got it. And how does this stack up against fine-tuning? A lot of organizations have already invested quite a bit in fine-tuning their models.
Right, good question. Fine-tuning involves actually training an AI model offline on domain-specific data to specialize it, so you're adjusting the model's internal weights. Context engineering, on the other hand, works at runtime. It guides a general model by providing it with context on the fly right when it's needed. Historically, teams might have fine-tuned models to inject corporate knowledge. Now, context engineering, especially through techniques like retrieval augmented generation or array, offers a really powerful alternative. Instead of baking knowledge into model weights, which, let's face it, can be expensive and require frequent retraining, you feed the model relevant, up-to-date knowledge at query time.
Okay.
This often achieves similar specialization, but with potentially less cost and definitely far greater flexibility.
So this really is a fundamental shift in how businesses need to approach AI development, not just a tweak.
It absolutely is. As one source put it, I thought quite powerfully, the era of vibe coding is over. Welcome to the age of context engineering, where systematic thinking replaces gut feelings. It's about treating AI prompting as a rigorous engineering problem. ensuring holistic context design by considering every piece of information the AI sees, focusing on relevance and precision, providing only intentional, filtered information. We're talking structured frameworks, dynamic inputs using real-time data, and iterative optimization with measurable feedback loops, much more like traditional software development, really.
Okay, so if context engineering is about systematically feeding AI the right info, what are the technical building blocks, behind the curtain? How do these systems actually pull it all together and manage this context? It sounds like it goes way beyond just simple API calls to a model.
You're right, it's definitely a more sophisticated engine. There are several critical parts working together seamlessly. At its core, it's about transforming your company's entire internal knowledge, everything from strategy docs to customer emails, into a hyper-searchable, AI-ready format. This involves preparing your data sources, breaking large documents into smaller, manageable chunks, cleaning the text, and then creating a kind of semantic map of that data.
Semantic map.
Yeah, think of it like that. This map is often stored in specialized vector databases. They're designed for AI to understand the meaning behind your information, not just keywords. It effectively turns your unstructured data into a real-time strategic asset that the AI can instantly leverage. It's far beyond simple keyword searches.
So it's like giving the AI a truly intelligent, organized library to pull from. Okay, makes sense. But how does the AI actually find the right piece of information from this potentially huge knowledge base when it needs it?
That's where the context retrieval mechanism comes in. It's commonly known as RA, or retrieval augmented generation. Think of it as the AI's intelligent researcher. When you ask the AI a question, the system semantically searches these knowledge bases for the most relevant pieces of information. It's a retrieve, then generate pattern. So retrieve first, then use that to generate the answer. This ensures the AI is always grounded in verified, precise information, which significantly boosts accuracy and reduces, well, guesswork. And there are advanced techniques, too, like combining semantic search with keyword filters or re-ranking results, just to make sure the AI gets exactly the right context.
Okay, so the AI is now this master researcher, finding the best sources before it even tries to answer. But how does it know how to use that information or what persona to adopt? And for ongoing conversations, how does the AI, remember what we've already talked about?
Right, those are key. That's where prompt templates and system instructions combine with memory and state management. Instead of crafting each prompt from scratch, engineers design reusable templates. These have placeholders. These templates define the AI's persona like, you are a helpful customer support agent. They set its scope, provide guidelines, and include slots where the retrieved data, user queries, or conversation history will be inserted dynamically. This ensures consistency and makes the AI's behavior predictable and more modular.
And the memory part.
For maintaining continuity in interactive apps, the AI needs memory. This involves short-term memory for the recent chat history. Often, this means summarizing relevant parts to fit within context window limits. You can think of that as the AI's short-term memory capacity for a single interaction. We use something called token budgeting to be smart about what information is most critical to feed the AI, making sure it gets precisely what it needs without being overwhelmed. And crucially, there's long-term memory. This uses external stores, like those vector databases we mentioned, to persist important information across sessions. This stops the AI from having to, say, derive the same conclusions over and over again.
What about when the AI needs to do more than just retrieve information, like, say, booking a flight or looking something up in a live database?
Yeah, good point. That's where tool integration comes in, often referred to as agents and actions. Modern context-engineered systems allow the AI to use external tools via APIs. The system tells the AI what tools are available and what they do. The AI then decides when to use one, executes it, and then feeds the tool's output back to itself as new context for its next step. So, for example, a travel booking AI agent could use a flight search tool, get the results, and those results become context for it to then decide, okay, now I need to use the hotel finder tool.
Right.
This massively extends the AI's capabilities far beyond its static training data, letting it perform real-world actions.
Wow, okay. That sounds like a lot of steps, potentially. How do you keep it all organized, especially for really complex tasks?
That's the role of workflow orchestration. Higher-end architectures break down complex tasks into multi-step workflows. An orchestration layer explicitly designs the flow. when to retrieve context, when to invoke the model, how to pass intermediate results from one step to the next. For instance, a workflow might first retrieve relevant documents, then ask the LLM to summarize them, and then feed that summary, plus the original user question, into a final prompt to generate the answer. This modular design helps avoid context overload and really improves reliability. Frameworks like LangChain and LambIndex are becoming widely used to enable this kind of modular, robust design in practice.
Okay, this is fascinating, but what's truly compelling for our listeners, I think, is the real-world impact. What kind of tangible results are businesses actually seeing from implementing this context engineering approach?
Yeah, the results are quite dramatic, actually. It's really moving AI from just promising demos to being reliable business tools. The most immediate and often impressive benefit is improved accuracy and reliability. Companies are reporting things like up to 10x higher model accuracy and a staggering 90% reduction in hallucination rates.
90%, wow.
Exactly. And we're hearing about 100x fewer production failures after moving from that sort of vibe coding approach to structured context frameworks. Grounding the AI in verified, relevant data fundamentally reduces errors and makes the AI outputs consistent and predictable.
That 90% reduction in hallucinations is really significant. Sure. Can you elaborate just a bit on why grounding the AI in verified data is so much more effective than just, say, trying to tune the prompt perfectly?
Sure. Prompt tuning, fundamentally, is often trying to coax or trick a general model into providing specific information it might not truly possess internally. This often leads to the model inventing facts, or hallucinating, when it hits the limits of its internal knowledge. Grounding it with context engineering means the AI isn't guessing. It's effectively reading from a provided source of truth before it answers. It's kind of like asking a student to answer a question. Instead of just letting them guess, you give them the relevant textbook page. The student, or the AI, might still interpret or synthesize, but the core facts are right there. This approach drastically cuts down on the AI just making things up.
I can definitely see that would be a game changer, and presumably this leads to faster development and iteration as well.
Yeah.
Sounds like more upfront work, maybe?
It might seem like more upfront structure, but absolutely, it accelerates development cycles overall by reducing guesswork. Developers spend way less time battling with prompts, trying endless variations, because the model is given the right information up front. Plus, these structured frameworks and modular components mean teams can reuse context modules. This leads to significantly shorter development timelines for new AI features. A task that might have taken dozens, maybe hundreds of intuitive prompt attempts can often be solved much faster with a few structured iterations.
And for any executive listening, the ultimate question is always higher ROI and business impact. How does all this translate to the bottom line?
Right, the crucial part. It hits the bottom line in several key ways. First, cost savings. Context engineering can be significantly more cost-effective than expensive fine-tuning, especially for injecting domain knowledge. Fine-tuning requires extensive data prep, costly compute for training, plus retraining for updates. A RAG, for instance, is more about upfront setup of data pipelines and then efficient retrieval at runtime. You can also often use smaller, cheaper AI models by compensating with rich, precise context, which cuts down on API calls and infrastructure costs.
Okay, so potentially lower operational costs. What else?
Second, better user experience and satisfaction. This is huge. When AI outputs are more accurate, relevant, and personalized because they have robust context, end users are simply much happier. We've seen examples like context-enriched AI assistants boosting e-commerce conversion rates by 10% and click-throughs by 25%. That directly improves customer lifetime value.
That's a direct revenue impact.
Exactly. And third, increased project success. There was a sobering statistic noted that something like 78% of AI implementations failed to meet business objectives. Many of these failures aren't due to the core AI model itself, but to integration issues, context problems, reliability. Context engineering directly addresses that gap. It transforms that cool demo into a consistent, reliable production system that actually delivers value. As one expert put it, skills in context engineering will determine the ROI of your AI adoption. It's becoming that central.
Can you give us some more tangible examples of this in action? Where are businesses really seeing these dramatic returns?
Sure. In customer support and chatbots, we saw an e-commerce bot using context engineering reduce the need for human support tickets by 40%. It achieved high customer satisfaction scores because it gave accurate, personalized answers based on order history and policy documents fed in as context. Similarly, a telecom troubleshooting assistant improved first contact resolution rate significantly by drawing on customer device configurations and network logs in real time.
So better service, lower cost.
Precisely. For knowledge management and enterprise Q&A, think internal systems. A global consulting firm built an internal AI assistant, context engineered with connections to their SharePoint and Confluence wikis. It now saves employees several hours a week of searching. Across a large firm, that equates to millions in productivity gains annually. We're seeing financial research assistants providing insights in minutes instead of hours by pulling context from market data feeds and internal reports.
And beyond internal uses.
In sales and marketing content generation, a B2B company doubled their content output for personalized marketing copy. They did this by feeding the AI-specific customer profiles and detailed brand voice guidelines as context. The result: double-digit improvements in email open rates and conversions. And even in highly regulated fields like legal and compliance, a law firm is using context-aware AI for contract review. Junior attorneys can complete reviews in a fraction of the time, and the firm actually increased its caseload by 30% without adding headcount. That's because the AI provided crucial context instantly from relevant laws and prior contracts.
Wow. Okay, so these aren't just isolated anecdotes. It really seems like a consistent pattern across industries. It showcases how context engineering is turning AI into a powerful, reliable business tool, moving it from the experimental lab right into the core of operations. So what does this all mean for businesses looking to implement this? It sounds incredibly powerful, but surely there are significant challenges to adoption.
Oh, absolutely. It's powerful, but not magic. There are practical challenges, both technical and operational. On the technical side, while models are getting better, there are still context window limits. You can't just stuff infinite information in. So we have to be smart about token budgeting, deciding what's most relevant, how to summarize or trim the rest, prevent information loss, or, just diluting the important stuff. There's also potential latency and performance issues. Multi-step processes like retrieval and tool calls can add milliseconds, which might matter for real-time applications.
Right, responsiveness is key sometimes.
Exactly. And the quality of retrieval is absolutely critical. The old garbage in, garbage out principle applies strongly here. If your system fetches irrelevant or incorrect data, the AI's output will suffer, no matter how good the model is. There's also the challenge of context mixing and interference, where sometimes multiple pieces of retrieved context might conflict or confuse the model. And thinking about long-term memory, there's even a risk of context poisoning.
Text poisoning.
Yeah, it's when a piece of incorrect or perhaps biased information gets embedded in the AI's long-term memory store, leading to repeated errors or problematic outputs down the line. Needs careful management.
Okay, so those are the technical hurdles. What about the enterprise-level challenges? What should leadership be really aware of when considering this shift?
Well, a big one, often the biggest, is data availability and quality. Many organizations still have data stuck in silos and messy, unstructured formats, or maybe of questionable accuracy. Building that solid, clean knowledge base that an AI can reliably draw from is a major undertaking itself. It's foundational. Then there are skill gaps and the learning curve. Context engineering is a relatively new discipline. Your existing teams might not be immediately adept. And without the right skills, you actually risk misuse, like accidentally exposing sensitive data through context retrieval if you're not careful. There's also the ongoing effort of maintenance and updating context. Business policies change, information gets updated, the context needs to keep pace. It's not a one-time setup. And finally, integration with existing systems, especially legacy IT infrastructure, can be complex.
And ethical concerns.
Privacy, absolutely critical. Data privacy and security are paramount. Feeding context means potentially exposing data, so you need robust access controls and ways to prevent context isolation failures between users or queries. And then there's regulatory compliance. You need careful attention to data usage, maintaining audit trails of what context was used for which output, and adhering to regulations like GDPR or others specific to your industry.
It really sounds like this isn't just a technical shift then. It's also a significant organizational and maybe even cultural one. How should companies prepare their teams for this new way of working with AI?
It absolutely is both. Preparation really starts with strategy. A good approach is to begin with high-impact, low-risk pilot projects. Maybe an internal employee help desk AI first, something to build internal expertise and demonstrate value without high external risk. You can also layer Gen AI onto existing processes to augment human roles, rather than trying to replace them immediately. This can ease the transition and make the technology feel less daunting. Crucially, investing in training and building cross-functional teams is vital. You need to bridge those skill gaps and ensure diverse perspectives, technical, business, legal, contribute to the design. And implementing a strong AI governance framework early on is key. It defines responsibilities, sets policies for data use and context management, and builds stakeholder confidence.
Okay, looking ahead then, what about the future? Where is context engineering headed in the next, say, 3 to 5 years?
The future here looks incredibly exciting, actually. We anticipate much greater automation of context management. Think self-reflective AI agents that can dynamically retrieve, filter, and even self-optimize their own context usage, basically, deciding what information they need on the fly without explicit programming for every case. We'll certainly see much larger and smarter context windows in the base LLMs, maybe handling entire books or databases as direct input. And the models themselves will likely get better at discerning relevance within those vast amounts of information. We should also see advances in true long-term memory and continual learning, allowing AI systems to genuinely learn from interactions over time without needing constant external memory resets or fine-tuning cycles.
And it won't just be about text anymore, will it?
Precisely. We're definitely moving towards multimodal context. AI processing images, audio, video, structured data tables, sensor readings, all as context. Imagine a manufacturing AI diagnosing an issue using sensor data plots, error logs from a machine, and the machine's schematic, all at the same time. This means context engineering itself will need to adapt to gathering, processing, and providing these diverse data forms effectively. This complexity will likely drive the emergence of a dedicated context orchestration layer as a kind of middleware, standardizing how context is managed across different models and applications.
And new roles.
Yes, I think the formalization of context engineer roles on AI teams will become much more common. People specifically dedicated to designing, building, and maintaining these critical context pipelines. And alongside all this, expect a greater focus on context security and governance. We'll need automated audit logs, better ways to trace context usage, and enforce policies to ensure not just any context is used, but the right, permitted, and relevant context.
Okay, so let's try and wrap this up. To summarize, context engineering really isn't just an incremental improvement. It feels like a fundamental shift. It's elevating AI from that experimental, often intuition-driven vibe coding to something genuinely enterprise-grade, driving substantial ROI and making AI a truly dependable business tool. We've heard how it dramatically improves accuracy, reliability, and development speed, translating directly into tangible business benefits, higher conversions, reduced costs, better customer satisfaction. This shift means AI can finally start to unlock your organization's proprietary data and processes, turning your unique internal knowledge into a real competitive advantage. So we really encourage you to explore pilot projects within your own organization, think about investing and upskilling your teams in this new discipline, and fundamentally rethink your AI strategy with a context-first mindset. It seems this isn't just a technical detail anymore. It's really becoming a strategic imperative for successful AI adoption.
And maybe a final thought to leave with. Imagine an AI that not only answers your questions based on solid context, but proactively anticipates your needs because it has such a deep contextual understanding of your business, your role, your current tasks. What new possibilities does that open up for your business? And how might that kind of capability completely redefine competitive advantage in your industry?
Thank you for joining the podcast, and see you soon.